Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 7, 7.9, and we're considering the vector equation of a line in 3 dimensions. Now, we've met the equations of lines before in Cartesian form, things like y equals 3x plus 2, y equals 2x minus 1. It's also possible to write the equation of a line in vector form. If we consider a line L, then the vector equation of the line is given by the position vector of the general point on the line. We'll call the general point on the line R, the origin we'll call O as normal, and what we want is to know how to get from O to R. To find R, which would be the position vector of the general point on the line. Well, to do that, we need to get to the line. So we need, first of all, to travel to a known point on the line, a point where we know its coordinates, we know its position vector, and we'll call that point A. Having got to the line, we then need to travel along the line until we get to R. That means we need to travel in the same direction as the line. And the way we'll do that is by using a vector which is parallel to the line, a vector which goes in the same direction as the line. And that vector we'll call D. Now, having done that, the vector equation of the line is given by R equals A, a point on the line, plus lambda times by D, the direction of the line. And if we look at the diagram here and the vector D, it looks like to get from A to R, you'd need about 3 times by D. So lambda would be about 3. To get to this point, lambda would be about 2. To get to this point, lambda would be about 1. To get to this point, lambda would be about minus 1. So lambda is a variable, and as it takes different values, you travel to different points on the line. Okay, example 1. Given the line L, where A352 is a point on the line, and D equals 4 minus 3, 7 is a vector parallel to the line, find the vector equation of the line. No tricks or catches here. You've just got to substitute these into the equation of the line, making sure that you write everything as vectors. Okay, pause the video, have a go, come back to me when you're ready. Okay, let's have a look. So a point on the line is 352. We just need to write that as its position vector, and then plus lambda times by the direction of the line. Well, a vector that goes in the direction of the line, we're told, 4 minus 3, 7. So that would be the equation of the line. But there are other ways of choosing to write down the equation. For instance, we could multiply out this bracket, bringing the lambda in, and then combining everything together in one set of brackets to get one vector. So we could also combine these to get the equation R equals 3 plus 4 lambda, 5 minus 3 lambda, 2 plus 7 lambda. We could also choose to use ij and k notation. So R equals 3i plus 5j plus 2k, where that's a point on the line, plus lambda into 4i minus 3j plus 7k, where that's the direction of the line. And again, we could multiply the brackets, combine these together so that you get the i's, j's, and k's separately. And that would give you R equals 3 plus 4 lambda times I, plus 5 minus 3 lambda times j, plus 2 plus 7 lambda times by k. You could meet any of these forms in a question. They all mean exactly the same thing. I would normally choose to use the first form just because it's slightly clearer. That's a point on the line. That's the direction of the line. But frequently, to do a question, you'll need to change between these forms. Okay, example 2. Find the vector equation of the line through 2 minus 1, 5 and 6, 8, 2. Finding a point on the line isn't a problem. We know 2 points on the line, and we can use either of them. Doesn't matter which we use. But we need to do a little bit of work to find the direction of the line. A and B both lie on the line, so the vector AB must go in the direction of the line. And that's the easiest way to find the direction vector for this type of question. Find the vector that goes from A to B. Okay, bearing that in mind, have a go at finishing this question off. Pause the video, come back to me when you're ready. Okay, let's have a look. So for the point on the line, we can use either of the 2 points we're given. I'm going to choose to use the first point. And then to find the direction of the line, the easiest way is to do the position vector of B, take away the position vector of A. And that'll give us the vector AB, which is 4, 9, minus 3. Now we can substitute those into the formula, and that gives us the equation of the line is R equals 2 minus 1, 5, a point on the line, plus lambda times by 4, 9, minus 3, the direction of the line. And as we said, there are many possible correct answers for this type of question. The point on the line A, that can be the position vector of any point on the line. Doesn't matter what point you use. And the direction vector can be any vector which is parallel to the line. In other words, it can be any multiple of 4, 9, minus 3. So for example, this would also be the equation of the same line. R equals 6, 8, 2, because that's a point on the line, plus lambda times by minus 8, minus 18, 6, because that's minus 2 times by the direction vector we used here. Okay, example 3. The line L has equation in ij and k notation as given here, and you'll notice they've used the letter m instead of the letter lambda. Doesn't matter what letter you use. And we're asked, do these points lie on that line? Now, the way you check that is you see if there's a value of m that works, that will give you that point for the answer. And the way I'm going to choose to write it down is combining these together to get one column vector. And then I'll have 3 equations, one for the I values, one for the j values, one for the k values. Each of those will allow me to work out the value of m. If I get the same value for all 3 equations, it means the point is on the line. If I don't get the same value of m for all 3 equations, the point is not on the line. Okay, have a go at seeing if you can make sense of all of that. So pause the video, have a go, come back to me when you're ready. Okay, let's have a look. So first of all, looking at the point 5 minus 10 minus 9, combining these together to create a single column vector will give me 3 plus m, 2 minus 6m, minus 5 minus 2m. And the question is there some value of m that will give me 5 minus 10 minus 9 for the answer? Looking first of all at the I values, 3 plus m is 5, which means m is 2. At the j values, 2 minus 6m is equal to minus 10, which also gives me m equals 2 for the answer. And then looking at the k values, minus 5 minus 2m is minus 9, and that also gives me m equals 2 for the answer. Now what that means is, if I was to substitute m equals 2 into the equation of the line, I would get this point for the answer. Therefore, the point P, 5 minus 10 minus 9, it does lie on the line when m is equal to 2. The second point we're asked to look at is 0, 22, and we'll do the same thing. So writing these as a single column vector would give me that. And the question is there a value of m which will give me 0, 22 for the answer? Looking at the I values, I get m equals minus 3. Looking at the j values, I get m equals minus 3 again. Looking at the k values, I get this, which simplifies to minus 2m is 7, which simplifies to m equals minus 3.5. So it nearly works, but it doesn't work. Therefore, Q022 does not lie on the line. Example 4. We're told that the line L1 has got that for equation, and then we're told that the line L2 has got this for its equation. And what we're asked is, are the equations of L1 and L2 alternative equations for exactly the same line? Now, we've already discovered that there are many, many ways to write down the equation of a line that can look very different from each other. We can use any point on the line. And when we look at the directions, we just need to have a direction which is a multiple of the other direction. So these could be the same line. The question is, are they? Now, to show that they're the same line, we need to do 2 things. First of all, we need to show that the lines are parallel to each other. If they are parallel to each other, we then need to show that there's some point which lies on both lines. And if both of those things are true, they must be the same line. Okay, I'll let you have a go at seeing if you can make sense of this. So pause the video, have a go at doing the question, Come back to me when you're ready. Okay, let's have a look. So first of all, we need to show that the lines are parallel. That means we need to look at their directions. The direction of the first line is minus 12i plus 4j minus 8k. The direction of the second line is 3i minus j plus 2k. Now, are these parallel? Well, they are if one is a multiple of the other. Well, D1 is a multiple of D2. It's minus 4 times by D2. That means that the two lines are definitely parallel to each other. To prove that they're the same line as each other, we still need to show that there's a point which lies on both lines. Now, we can choose any point. I'm going to choose n equals 1 in the second line and see what point that gives me on the second line. So putting n equals 1 into the second line, I would get this, and then adding those two brackets together gives me the point minus 7i plus 8j minus 9k. So I know that that point's on the second line when n is equal to 1. The question is that point also on the first line? If it is, then they're the same lines. So going back to the first line and combining these two brackets together so that the i's are done separately, the j's are done separately, and the k's are done separately, I get 2 minus 12m times I plus 5 plus 4m times j minus 3 plus 8m times k, which would be the equation of the first line. And the question is there a value of m that will give me minus 7i plus 8j minus 9k for the answer? And again, the way we do that is we look at the I, j, and k values separately. So first of all, looking at the I values, 2 minus 12m equals minus 7. That would give me m equals 3/4. Looking at the j values, 5 plus 4m equals 8. That also gives me m equals 3/4. And then finally, looking at the k values, minus 3 plus 8m is equal to minus 9. And that also gives me m equals 3/4. Now, what that means is that this point is on both lines. It's on line 2 if n is equal to 1. That was the value I chose. It's on line 1 if m is equal to 3/4. But it's on both lines. The two lines are parallel. Therefore, L1 and L2 are exactly the same straight line. They're just two different ways of writing down the same thing. Okay, final question. Example 5. We're told that these 3 points, A, B, and C, are collinear. That means they lie on the same straight line. First of all, we're asked to find the values of alpha and beta. And then secondly, we're asked to find the vector equation of the line that goes through A, B, and C. Now, the way I'm going to find alpha and beta is I'm going to consider two vectors, the vector AB and the vector AC. Now, because they're collinear, that means that the vector AB must be parallel to the vector AC. That means the one vector must be a multiple of the other vector. Now, that's how I'm going to get started on this question, but I'll let you have a go at finishing it yourself. So have a go, see if you can make sense of it, pause the video, come back to me when you're ready. Okay, let's have a look. So to find the values of alpha and beta, I know that AB must be parallel to BC because all 3 points are on the same line. Therefore, B minus A must equal a multiple of C minus B. Now, B minus A, that's 5 minus alpha, 4, and beta minus 8. It must equal a multiple of C minus B, which is minus 4, minus 8, 3 minus beta. Now, that gives me 3 equations with 3 unknowns, but the middle one only has m in. So looking at the j value, I get 4 equals minus 8m, which means that m must equal minus 1/2. In order to work out the value of alpha, I'll go to the I values. So 5 minus alpha equals minus 4m. Substituting in m equals minus 1/2 would give me that. And that eventually simplifies to alpha must equal 3. To find the value of beta, I'll go to the k values. Beta minus 8 must equal m into 3 minus beta. Again, substituting in m equals minus 1/2 will give me that. And that simplifies to this, and then I get beta is equal to 13. So alpha is 3, beta is 13, if those 3 points are collinear. And then we're asked to find the vector equation of the line through A, B, and C. Well, I'm going to use the point A as the point on the line, and I know that alpha is equal to 3, so I can now substitute that in. So A becomes the point 3, 3, 8. And for the direction of the line, I'm going to use the vector B minus A, which we said was equal to 5 minus alpha, 4, beta minus 8. And I can substitute in alpha and beta, and that will give me 2, 4, and 5. Therefore, the equation of the line that passes through A, B, and C is R equals 3, 3, 8, a point on the line, plus lambda times by 2, 4, 5, the direction of the line. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 129 and have a go at exercise 7i. Thanks very much for listening, and cheerio.